Okay, Assalamualaikum warahmatullahi wabarakatuh. In this time, we will learn about nuclear and radioactivity. At the first, let's look the history of nuclear and radioactivity. The first time research on nuclear began in 1896 by Anthony Becquerel, who discovered the nature of radioactivity in uranium element. The next research in 1902, Mary and Pierre Curie was able to isolate radioactive metals, namely radium. Then in 1995, Albert Einstein put forward a theory called a special theory of relativity. On the next research, in 1934 by Enrico Fermi, who unconsciously discovered a nuclear reaction they call fission. And on the 1945, nuclear bomb firstly dropped in Hiroshima and Nagasaki. Okay, before we learn further, let's define about nuclear. Nuclear is the separation of large nucleus into small nuclei, while radioactivity is an atom decay which releases alpha particles or beta particles or gamma rays. Let's see the graph NZ, which states the ratio of the number of neutrons and the number of protons. Based on the theory of semi-empirical mass formula, it was found that the stability of a nucleus is when the ratio of the number of protons and the number of neutrons is in accordance with the curve. This shows that the stability of an atomic nucleus in an element with a large nucleus is if the number of neutrons is greater than the number of protons. When a core is unstable, the core must be decayed. This decay process will produce the new element called radioactive element. There are various kinds of radioactive emission. The first is alpha decay. Alpha decay will release 2 protons and 2 neutrons, like the nucleus of a helium atom. For example, the element uranium with the number of protons 92 and the number of nucleon 238 will turn into thorium element with the number of proton 90 and nucleon number 234. There is a reduction in the number of protons from 92 to 90, reduction in the number of nucleon from 238 to 234. The second is beta decay. Beta decay occurs in atoms with nuclei that have excess protons or neutrons. For example, the element rhenium with the number of protons 75 and the number of nucleon 187 will change to osmium with the number of proton 76 and the number of nucleon 187. There is an increase in the number of proton from 75 to 76, but the number of nucleon remains. This is because rhenium has excess neutron, so that neutrons turn into protons and cause an increase in the number of protons. This processes release electron and antineutrino particles that carry a certain amount of decay energy. This decay is called negative beta decay. There is also positive beta decay. The difference is that an element has an excess of protons, so that the new element formed will have a smaller number of protons and than the original element, but the same number of nucleons. This is because the proton has turned into a neutron. Positive beta decay releases positrons, which are positively charged of electrons. Positive beta decay releases positrons, which are positively charged electron and neutrino. And the last is gamma decay. After alpha and beta decay, the nucleus is usually excited. Like atoms, the nucleus will reach a ground state by emitting photons or electromagnetic waves known as gamma rays. In the processes of transmitting these photons, neither the atomic number nor the core mass number changes. For the example, thorium that in excited state with a number of proton 90 and a number of nucleon 234 will change into stable thorium with the same of the number of proton and nucleon by emitting gamma rays. Okay, that's our discussion of nuclear and radioactive. I hope it can give understanding to you. And let's close with kafaratul majlis prayer. Subhanakallahumma bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.